All right, everybody, welcome back to the channel and welcome to today's video. And boy, do I have a good one for us today. Our friends over at eSun have sent us some of their brand new high-speed PETG filament in this cool yellow color. Now, they do recommend drying this filament, so they also sent me the eBox Lite in order to dry the filament, so we'll be using that. So we'll go ahead and get the filament dried. Then we'll jump into Orca Slicer this time, and we'll go ahead and calibrate the filament. We'll print out one of our cool little benches, and we'll print out one of our samples as well, and we'll see what the color looks like on this, and we'll see how well it prints and how well it calibrates on the PEI textured plate. So, if all of that sounds good, then sit back and relax, and I'll get everything ready. All right, so let's get the filament dryer set up and we'll get the filament dried. All right, so now let's get our filament unboxed. And then on the manual online, it says that setting number 2 is for PETG. So we'll do that. And you'll notice this only has 3 settings on the temperature here. We'll put it on number 2. And I'll see you when it gets done drying. All right, so as that filament is drying, let's go ahead and take a look at the website here. And here is the website for the PETG high speed here from eSun. And then under parameter information, it does say to dry it for more than 3 hours. So I put it on the PETG setting for the eBox Lite and dried it for a little over 3 hours. And you'll see they have a bunch of colors on here, and they are having a sale for the holidays right now. So if you're watching this when the video comes out, they are having a sale. And then this is the eBox Lite that I have here. And it shows all of the different materials that it'll dry as well, which I think is pretty cool. It uses less energy than your bamboo would. And if you don't have an enclosed printer and need to dry something like TPU or something, I think is on here as well. Yeah, then you'll be able to do that with this. And they also have a larger one as well, this eBox. And that gets to some higher temperatures and probably does stuff a little bit faster and everything. And it looks like you can keep the filament in here and then print from it. I won't be doing that. I'll only be using this to dry the filament. But that is that. So now, once the filament dries, let's go ahead and get it loaded into the AMS. All right, so here we are in Orca Slicer, and as you can see, we have the PETG loaded in the first slot of the AMS there. So we'll go ahead and start with the temperature test. So we'll click on temperature, and we'll want to make sure to click on PETG, hit OK. That's going to set up our model. We'll go ahead and slice it. It's going to take about 46 minutes, so we'll go ahead and print that, and I'll see you when it gets done. All right, so here is a picture of the temp tower, and I will say between the 230 and the 235, and I think I'm going to go with the 235, looks the best out of them all. And again, I took several pictures of it and, just zooming in and out of the pictures and looking at everything there. This one seems to be the one with the least defects, so we'll go with 235. So let's jump into Orca Slicer. All right, so what we'll want to do now is go to new project to get rid of all of the settings and everything that are in there. And we don't want to save it. Discard. So now we'll go into our filament here, and it shows, standard at 230 or 255 here. And I thought that the 235 worked the best there. So now we will save this, and we'll save it as eSun high speed PETG. All right, now that we have everything cleared out, we have that saved, we have our filament saved up here. Let's go to the next calibration, which is going to be the flow rate. And we'll set up the first pass, which is these little tabs here, and we'll go ahead and get that sliced. And so if you remember what these tabs do is this is the flow rate at 0, so what it's at right now, and it does a bunch above, more flow and less flow, minus 20 and plus 20 in between, and we're gonna find out which one is the best pattern. And really, after this prints, the trick here is to take a picture of it again and be able to zoom in. So this takes about 30 minutes. So let's go ahead and get it printed out, and I'll see you when it gets done. So here we are with the picture of the flow rate, and as we can see on the over and on the under, pretty easy to see the -5. You can see a lot of ridges there. The 0 and the 5 look about the same. And if you remember from previous things, always go with the higher one. So let's go ahead and open up Orca Slicer and go to the wiki so we can do the math for 5 as the modifier here. All right, back in Orca Slicer, the first value that we need is what our old flow rate is, which is 0.95. So we'll want to write that down. Let's go to the calibration and go to the tutorial. And here we'll see the math for the flow rate. All right, so our old modifier was 0.95. And we need to multiply that by 100 plus our modifier, which is 105. So 0.95 times 105 equals 99.75 divided by 100 is 0.9975. So that's what we need to change our flow rate to, and then perform the second test. So let's go back into Orca, and right here under flow ratio, we'll want to change that to 0.9975. And we're going to go ahead and hit the save button and save that. We're going to go to new project, don't save, discard everything. And now we'll do the second pass of the flow rate test. And this will fine tune it the rest of the way, and we'll need to do that math one more time. So let's go ahead and slice the plate. This one takes about 35 minutes, 33 and change. And same thing on this one. We'll want to take a picture of this and figure out which one of these looks the best. So I'll go ahead and get that printed out, and I'll see you when it gets done. All right, so here we are back on the flow rate second pass, and this yellow color is a little bit harder to see, but you can see the separation between all of these with the -1 to me, and I did the field test as well, but the -1 feels the best to me. So let's put that back into the math and get that calibrated. All right, so back in Orca Slicer, so our starting value now is going to be the 0.9975. We'll exit out of there, go to the tutorial. So 0.9975 times 100 plus our modifier, and our modifier is -1. So 100 minus 1 is 99. So 0.9975 times 99 is 98.7525 divided by 100. 0.987525. We'll only go out 4 places, so 0.9875 is what my calculator says. So let's go back into Orca Slicer and put that in. So we'll go back into the filament here, and basically it's just 0.9875. We're going to want to save that. So we've adjusted the temperature, we've adjusted the flow rate. The next thing that we're going to need to do is the pressure advance. We'll go ahead and save that with pressure advance enabled. All right, so now that we have everything saved in here, let's go ahead and exit out of there. Let's go ahead and hit new project. We don't want to save anything. We want to discard all of the options there. As you can see, when we go back into our filament, everything is the same. We have our pressure advance done. So now we'll go ahead and do the pressure advance test, and we'll want to do the line test. We'll do that. You'll see that it shows up like that until we hit OK, or until we hit the slice plate. And this only takes about 13-14 minutes. So we'll go ahead and get this printed, and I'll see you when it gets done. All right, and here is the line test, and you'll see that they put a background against these numbers. I used to always have a problem with these numbers peeling off right here. So this is really, really cool. So really what I look for on this test is you'll see that there's kind of a pattern on the left and the right, and I see where that kind of ends, and then I look for the line that looks the best and the straightest right here, right in here and right in here. And I took several pictures of this, but this is the best one for where we want to calibrate it to, and really that 0.024 really looks the best to me. So let's go in to Orca, and we'll change the pressure advance to 0.024. All right, so here we are in Orca. So let's go ahead and hit new project. No. And then now let's go into here and change our pressure advance to 0.024. And we'll go ahead and hit the save button there. Then we'll move on to the next calibration. And that last test will be the max volumetric speed test. Now, with this test, I probably won't ever put a filament over 20 millimeters cube per second or whatever. And if you look at my ludicrous video, what we found out, or what I found out, is really this only affects when you're doing really long prints in ludicrous mode. Otherwise, the filament can kind of handle all of the settings there, or we can kind of, I've never really seen it do this, but we'll try to push it to its limits on there. But really, I've only seen this kind of, birds nesting or whatever happen when you're doing really long prints at the ludicrous speed. So let's go ahead and do the max volumetric speed test. And that's under max flow rate, max volumetric speed test. So the start volumetric speed is 5 and the end is 20, which I think it can handle all of that. And right now it's set at 7.5. So it can handle that. I normally run most of my filaments at 15 just because I found that that's been comfortable, but let's see if we can push this one over the top today. So what we'll start it at is at 10, and we'll end it at 30, and we'll do increments of 5. there. So it'll be a little bit more of a test than it was before, but we're not starting at as low as a speed. So we'll go ahead and hit OK on there. And we'll see that it gives us this pattern here. And when we slice it, the thing that you want to look at is the speed right here. And this is where it's going to show you all of the different speeds that it's going to travel. So we'll put it back to line type. And this test takes about 37 minutes. So we'll run it on there and we'll see if we can get it to fail above 20. I'll see you when it gets done. All right, and as you can see in the video and the picture here, right at the very end here, it did start to fail, but it did handle business all the way up. I would say 20 is probably right around in this area, and that's where it started to separate, and that would be the max I would say that it could do. So that's what we're going to set it at. You know, I've never really set it past 20, and I'm glad I did because it did finally fail, but it was up above 20. So let's go back in Orca Slicer and change the max volumetric speed. All right, so let's go ahead and get rid of everything by hitting new project, don't save, discard everything. And then we'll go back into here, and at the very bottom, oh, I guess it was at 12, not at 7.5. Some of them are even lower, but it was already set at 12. Let's set it to 20 and go ahead and save that. All right, now that we have all the calibrations done, it's time for the benchy. So let me get the benchy loaded and we'll get it printed. All right, there we have the benchy. So we'll go ahead and slice it. We'll see 1 hour and 7 minutes, and that max volumetric speed does have an effect. So if we put it back to the 12 that it was at before and slice the plate, you'll see that it adds 4 minutes to the total print time, and that's per hour. So if you have a really long print, 4 minutes every hour is pretty significant. So trick here, if you don't want to go back there and change it and hit save and do all of that, we can just hit this revert button and it'll put it back to 20. Let's go ahead and reslice it, 1 hour and 7 minutes. So let's get this printed. All right, now that the benchy is done, we'll go ahead and get the sample in there, and we'll go ahead and hit slice plate. This will take a little over 40 minutes, and I'll see you when it gets done. All right, so take a look at the benchy here, and you can see that it's almost perfect. There's one little spot where it's had a little bit of an error, but otherwise it is perfect. And then if you look at the sample, same thing there. Everything came out super good. This is really cool stuff. I haven't done very much with PETG up to this point. Mostly everything's been the carbon fiber, PLA, and here lately lots of ABS and ASA. So I haven't done a whole lot of PETG, so it was kind of cool to do a PETG filament tuning today, or calibration. So that was kind of cool, and it was just as easy to calibrate as anything else, and the results, as you can see, are perfect. and it came out really good. So I have a cool roll of PETG. Leave a comment below on what I should use that roll of PETG for, and then I will print it out with that. So be sure to smash that like button. Be sure to hit the subscribe button so you don't miss next week's video. And I hope everybody has a great week and a great week leading up to the holiday season. Thank you, everybody, and thank you. Thank you.